So you've got these three charges arranged as shown in this figure. Q1 is at the origin, and 52 centimeters away on the x-axis is Q2, but 30 centimeters above that on the y-axis is Q3. And in part A of this problem, you want to figure out what is the net electrostatic force on Q3 due to the other two charges. So we're going to look at each one individually. What's the force on Q3 due to Q1, and then what's the force on Q3 due to Q2. Well, let's start with the force between Q1 and Q3. We'll first put the direction on there. So since Q1 is positive and Q3 is also positive, that means these two charges are alike, so they're going to repel each other. So Q3 is going to be pushed away from Q1, so we can put an arrow pointing upward. And if we do the same thing for Q2, Q3 is positive, Q2 is negative, so those two are going to attract each other. That means Q3 is going to be pulled toward Q2. So we can do another arrow going down this way. So depending on the magnitude or the length of those arrows, the charge is more than likely going to be moving somewhere in that direction, to the northeast. So we need to figure out exactly. So the first arrow we're going to call F31. That's the force on charge 3 due to charge 1. And the second arrow we're going to call F32, the force on charge 3 due to charge 2. And we need to figure out what each of those are. So F31, we're going to use Coulomb's law, is K, the two charges, which are Q1 and Q3, divided by the distance between those two charges, which is labeled as R13 or R31, either way is fine, squared. If you plug in all the numbers, K is 9 times 10 to the 9th, Q1 is 50 times 10 to the negative 6, Q3 is 65 times 10 to the negative 6, and R13 is the 0.3 meters, and that's going to be squared. You plug all those in, you'll get an answer of 325 newtons. Do the same thing for the other arrow, F32. So this is the force on charge 3 due to charge 2, so it's K. Do the two charges, which are Q2 and Q3, and the distance between the charges is R23, and that's squared. We don't know what R23 is, but we do know R13, and we know R12, and we know there's a relationship between those with the Pythagorean theorem. But rather than take R23 and as the square root of the sum of these two sides squared, since we're looking for R23 squared, we could actually just write it in the form. We know that R23 squared, which is the hypotenuse, is equal to R12 squared plus R13 squared. That is the Pythagorean theorem before you take the square root. So we can actually, since we're looking for the R23 squared, we can plug that in directly right here. So the K is 9 times 10 to the 9th. The Q2 is 86 times 10 to the negative 6. Remember, don't put the negative signs in these equations. We take care of the negatives later when we deal with direction. The Q3 is 65 times 10 to the negative 6. And the R23 squared is going to be down here. It's the 0.52 squared plus 0.3 squared. You can put all that in for the bottom. And when you do all that, you'll get an answer of 140 newtons. If you want to put the directions on these, this one is going to be upward, straight upward. You can say at 90 degrees. The second one, the F32, if you had to calculate this angle right here using inverse tangent, you know the opposite side and the adjacent side, you would find that that angle is almost exactly 30 degrees. So you can say the angle for this one, or the direction, is 30 degrees below the x-axis. Or you could just put a negative sign on there, negative 30 degrees. So we're still in part A. We want to figure out the magnitude of that force now. So we have to break these vectors down into vector components. So we're going to take the F31 and get an x component and a y component. So F31x and F31y. And then we want to do the same thing with F32. We want to get an x component and a y component. So F31x, since that one's completely in the y direction, the x component is going to be 0, and the y component is going to be what it was equal to, which is 325 newtons. For the F32x, we need to break it down as F32 times the angle's taken with respect to the x-axis. So this is going to be F32 cosine theta, and this is going to be F32 sine of theta. And notice that the x component is positive because it's pointing toward the right, but the y component is negative because it's pointing downward. When you do all the components for that, you should get an F32x of 121 newtons and an F32y of negative 70 newtons. Now we can add them together, the x components, F31x and F32x, so that'll give you the resultant vector, which I'm just going to call F3 in the x direction, is 121 newtons, and the F3 in the y direction, which is 255 newtons. And that comes from 325 minus the 70. So now we have the x and the y components of the total vector. So now we can just get the magnitude and direction using the Pythagorean theorem and the inverse tangent. If you take the Pythagorean theorem of those two numbers, you'll find that F3 is equal to about 282 newtons, and the angle of that is roughly about 65 degrees above the x-axis. So that's your final answer for part A. For part B, where could you place a fourth charge that's negative 50 microcoulombs so that the net force on Q3 would be 0? Well, we already said that the net force is going to be somewhere up in this region right here, and it's actually at 65 degrees to the axis, so this angle right here would be 65 degrees. The net force is 282 newtons, so we want to place a force, we want to place a charge to cancel out that net force. Since it's a negative charge that we're placing, and Q3 is a positive charge, they would attract each other, so we want to actually place that charge somewhere around here. So that will be the Q4, so that it attracts the Q3 toward it enough, hopefully, to cancel out this force exactly. To figure out the distance of that, we use Coulomb's law, but rearrange it for the R34, that's the distance between charge 3 and charge 4, and that's equal to the square root of K Q3 Q4 over F34. That's the force on charge 3 due to charge 4. And we know that this down the bottom has to be exactly equal to the 282, so it'll cancel it out. And when you plug in those numbers, the K is 9 times 10 to the 9th, the Q3 is 65 times 10 to the negative 6, the Q4 is 50 times 10 to the negative 6, the F34 is 282, you'll get a final answer of 0.32 meters. So you can say for the answer that it is going to be 32 centimeters southwest of Q3 at a 65 degree angle if you want to be really precise.